Okay, so the 11th question is actually pretty silly to do. So just 1 plus x power n, and then you just integrate this thing from -1 to 0, and then you get this answer. Okay, so I'm not going to go into the complete detail on how to do that because it's very easy. You can do it on your own. Let's go to the 12th question in that case. So it's c1 upon 2, c3 upon 4, pretty much the same thing as what we saw on the 11th one, except that some things are actually missing over there. So it's also the same thing, you just integrate from -1 to +1, and that should be it. That should give you this answer. Okay, let's go to the 13th one. So it's 2 into c0 plus 2 squared into c1 upon 2 plus 2 cubed into c2 upon 3 and so on. So you guessed it, just integrate from 0 to what you call it, from 0 to 2, right? So it's going to give me 3 power n plus 1 minus 1 upon n plus 1. So yeah, that's actually pretty easy. So what about the 14th one? So 5c1 plus 9c2 plus 13c3. So notice that the difference is of 4 everywhere. It's like 5, 9, 13 itself is 4. And then plus 1 c power n is equal to 2 power 2n plus 1. Hey, that's really nice. So let's do this. So 1 plus x power 4 to the power of n. Yeah, that will turn out to be this thing. So like that will turn out to be nc0 plus nc1 x power 4 plus nc2 x power, wait, is that really correct? Yeah, x power 8 plus nc3 x power 12 and so on. It's like ncn x power, I think 4n. Yeah, so let's multiply this series by x. So it's going to be x over there, it's supposed to be 5, 9, 13, 4n plus 1, right? Now let's take the derivative. So it's going to be, well, the derivative of this thing is like 1 plus x power 4 to the power of n plus n into 1 plus x power 4 power n minus 1. Well, the derivative of 4x, sorry, x power 4, that is 4x cubed. So it's supposed to be 4. Then x cubed times x is x power 4, right? And that is supposed to be nc0 plus uh, nc0 plus 5 nc1 into x power 4 plus 9 nc2 x power 8 and so on, right? And we want this to be positive, so you will just put 1 over there. That should make sense. So put 1 in there, you get 2 power n plus 4n into 2 power n minus 1. Yeah, that thing is supposed to be 1 plus the sum, so that's going to be like 2 power n minus 1. Hey, wait, actually 4, that's still 2 power 2. This is going to be 2 power n plus 1. So this is actually equal to 2 power n into 1 plus 2n, right? So 2 power n into 1 plus 2n minus 1, that will be the value of our sum. So this one is also done. Let's go to the 15th question in that case. The 15th question is c0 upon 2, c1 upon 3, c2 upon 4 and so on. Yeah, that's actually also very easy. All you gotta do is use 1 plus x power n, the series for that thing, and then multiply that thing by x, and then take the then take the integral, right? And evaluate that thing from 0 to 1, and that's gonna give you this answer. Okay, so I won't be doing this. Yeah, what about the 16th one though? So it's almost the same thing. So like you take uh the integral of x into 1 plus x power n, right? And then you evaluate it from -1 to 0, I think. Yeah, so like x squared by 2, isn't it? Yeah, so you do evaluate it from -1 to 0, but then what you do is that you take the negative version of that thing. So that's going to give you this sum, and that should turn out to be that. Uh, yeah, 1 upon n plus 1 into n plus 2. Actually, let's do the 16th one because I'm curious to see if it really turns out to be that beautiful of an answer. Okay, so we know that 1 plus x power n into x, that's supposed to be equal to nc0 into x plus nc1 into x squared plus nc2 into x cubed and so on. So if we take the integral, this will turn out to be like, wait, what? X into 1 plus x power n. Oh no, the integral of that thing, that's gonna be, oh no, that's, now we have to use integration by parts. I mean, we are not taught integration by parts yet, but we have to use it anyway. So yes, like the integral of x 1 plus x power n dx. So I'm going to differentiate this thing and I'm going to integrate this thing. Okay, so what do we do? Well, first of all, integrate wait, what am I, it's supposed to be 1 plus x complete power n, isn't it? Actually, why am I doing this using integration by parts? There's an easier way out, right? This is like the integral of 1 plus x power n minus, sorry, n plus 1 minus 1 plus x to the power of n dx, and then we can just integrate this using substitution. So that has to be equal to um so like d of 1 plus x. I know it sounds really weird, but trust me, that's how I do it. So it's like 1 plus x to the power of n plus 2 upon n plus 2 minus 1 plus x to the power of n plus 1 upon n plus 1. And from where to where should we go? So I think it should be from -1 to 0, right? So that's going to be equal to, so when you put 0 over there, well, that thing actually completely cancels. So like nc0 x squared by 2 nc1 x cubed by 3 and so on. So it's like from -1 to 0. So when you put 0, you just get 0, and then minus, when you put -1 over there, you get nc0 upon 2 minus nc1 upon 3 and so on. Is that what we want? Yes, that's what we want. But then you want this to be in the negative version of this, right? So that's going to be like 1 plus x to the power of n plus 1 upon n plus 1. uh, Wait, what am I doing? I think that's correct. Okay, so 1 plus x power n plus 1 upon n plus 1 minus of 1 plus x power n plus 2 upon n plus 2, right? And this thing evaluated from -1 to 0. So just take a negative on both sides. So that's going to be our answer. Yeah. So you put 0 over there, this becomes 1 upon n plus 1 minus 1 upon n plus 2. When you put -1 over there, this completely vanishes. So like this thing is actually equal to 1 upon n plus 1 into n plus 2. Yep, this is correct. So yeah, the 16th one is obviously correct. So that's it. We did all these questions. Cool. I will see you in the next one.